Hello everyone, I am Snigdha Kakkar and this is my YouTube channel Accelerate AI Careers. This is the 7th chapter to my complete free playlist for generative AI and 5th chapter to my NLP playlist. It's targeted to help you start at a beginner's level, become acquainted with the theoretical as well as practical concepts in this field. We'll also do hands-on projects in parallel that will help you understand the concepts and ingrain them in your basic nature. In the last few sessions, we covered some interesting text pre-processing topics such as tokenization, stemming, lemmatization, stop words, parts of speech, and named entity recognition. If you have not watched my prior videos, I would suggest you to first watch those videos and get acquainted with all those concepts before proceeding with this particular playlist. In today's session, we will look at what are the different ways we can convert text into vectors. So if you like my sessions, please like this video, subscribe to my channel. If you feel that I should prioritize some essential topics in this field, please mention it in the comments here. So let us begin our learning journey. The topics we would cover are going to be one-hot encoding, bag of words, TF-IDF, word to vec, average word to vec. The first topic is one-hot encoding. So here we'll start with an example where we have 3 sentences, S1 which is the trip is good, S2 the trip is bad, and S3 Italy is amazing. Now the output for them is 101 depending upon whether it is positive sentence or it is a negative sentence. Now how do we find out a list of unique vocabulary using one-hot encoding? How do we do that? So on the right side you can see here that the unique words would be the trip is good, bad, Italy, amazing. These are the unique words. So this is a set of your vocabulary. So I'm just writing them down here on the right side. Each word is basically represented by a vector with the dimension v. Now what's v here? The unique vocabulary v is going to represent these vectors. If you see the dimension shape here, the unique vocabulary v is going to represent these and the shape is going to be 4/7 for each word, where 4 is the number of words in each sentence and 7 is the number of words in the vocabulary. So now how do we get the representation? So on the right you can see for word the only one would come in place of the rest of the words will have zeros. Same way for word trip would have 1 and the rest of words would have zeros. So this would be incorporated for each sentence. So now say suppose we are doing for sentence S1. So if you see on the left side, how we go about is the word the will have 1 in its first place and rest will have zeros. Same for trip. The second one would have 1 and rest will be zeros. Same way we have done for is and then good. And this set of all the vectors, a combination, is going to make one vector for each sentence. So S1 will have 4 vectors in it. So it will be a matrix basically. Same way for the trip is bad. The sentence S2 has been coded here. Same way for sentence S3. So basically the shape of each vector is 4/7 or 3/7 depending upon what's the length of each sentence, how many words are there in each sentence, and how many words are there in the vocabulary. This is a very intuitive, very easy but effective technique of one-hot encoding. Based on your unique word or vocabulary size, the shape of the vector changes. Now we will see what are the advantages and disadvantages of using one-hot encoding, followed by some other techniques we can use for converting word to vectors. So when we talk about advantages and disadvantages, the biggest advantage here is, like I said, it is intuitive. It is quite easy to implement. And there are specific libraries in scikit-learn such as one-hot encoder, and in pandas you have pd.getDummies, which you can use to implement one-hot encoding. Now what are the disadvantages? So to highlight the disadvantages, I will take one example. Say on the top, I have taken food, pasta, spaghetti, and you have the vector representation for it. We will refer to it while discussing the disadvantages. The first disadvantage is there is very less 1 and there are so many zeros, right? So this is a sparse matrix, which leads to overfitting. Basically, overfitting is when it trains and performs really well on seen data, but underperforms on unseen data. This sparse matrix leads to overfitting. The second disadvantage is with one-hot encoding, we are not getting fixed size input. Depending upon how many words are there in the sentence, the dimension of your vector or the shape of your vector changes. Like for the first and second sentence, the number of words were 4 in the prior examples, so the dimension was 4 by 7. Whereas the third sentence has only 3 words, so the dimension was 3 by 7. We are not getting a fixed size vector or a fixed size input, which is needed for machine learning algorithms. The third disadvantage is that it does not capture the semantic meaning behind those sentences. So, as you can see from this example, food, pasta, spaghetti, they are all food items, right? So, there should be some correlation shown between them using these vectors, but they are being treated as different entities and there is no correlation coming up. They are all 3 different items. It does not tell how much similar one word is to another or how much different one word is from another. So, there is no semantic meaning being captured there. The fourth biggest disadvantage is out of vocabulary. So, say, suppose you get a fifth sentence where the sentence is like S4, junk food is bad. So, now there are 2 new words introduced, junk and food. These new words are not there a part of your vocabulary, so they will be rejected while doing one-hot encoding. This is a big disadvantage because large number of sentences might have large or big number of sparse matrices and there would be so many out of vocabulary issues due to unseen words and sentences coming to as an input. Now, to overcome these disadvantages, we will look at other vectorization techniques, other encoding methods, and the second one we are going to explore is bag of words. So, this bag of words technique, we will lead with 3 examples. S1, Italy is a good vacation. The output is 1 because it's a positive sentence. S2, beach is a good outing. Again, a positive sentence. The output is 1. S3, vacation and outing are good. Again, a positive sentence. The output is 1. Now, I would first implement lowercasing and then removing of stop words. What stop words are, how we remove them have been addressed in prior video. But for your information, I will tell words like is, and, are, which are meaningful but do not add much to the sentence processing steps we are going to take further. We remove them. So S1 will reduce to Italy, good vacation. S2 will reduce to beach, good outing. And S3 will reduce to vacation, outing, good. So these will be your deductions of sentences after lowercasing and stop words removal. Now, what are the unique words in this vocabulary? So these unique words in the vocabulary, if you see, are good, vacation, outing, Italy, and beach. So there are 5 words altogether. And they have been ranked as per their frequency. So the frequency for good word is 3, vacation is 2, outing is 2, Italy and beach is 1. So if you see, it is aligned from max frequency to min frequency. Before applying bag of words, we already can see the size of frequency and it is not necessary to use all the words in the vocabulary. Say we have 100k unique words and some of them have 1 frequency. We can actually pick important features during feature selection process as per the topmost frequency. Now in one-hot encoding, for every word we had 1 vector. In bag of words, for every sentence we have 1 vector. We will look at its advantages and disadvantages as well. Now let's represent them as vectors. So in our vocabulary, we have words good, vacation, outing, Italy, beach. So we have laid out in the right side like this. And the output of sentences has been listed as 1, 1, 1. For each sentence, whatever word is present in them gets 1 and whatever word is not present gets 0. So that's how the vector representation has been obtained. So now these vectors can be taken and a machine learning algorithm can be trained on such a data. Now suppose in sentence 1, the word good is appearing twice rather than 1 time. Then in the vector for sentence 1, the frequency of good would be 2 rather than 1. There are 2 things, binary bag of words and bag of words. So if we are talking about binary bag of words, irrespective of the frequency, it will force the frequency in the vector to be appearing as 1 or 0. It will not take any other value. Thus, binary bag of words would comprise only of 1 and 0. Whereas normal bag of words can have any number as the frequency of words depending upon how many times the word has appeared in the sentence. Now let's look at some of the advantages and disadvantages of this type of encoding bag of words. So one advantage for this particular technique is that it is easier to implement. It is intuitive as one-hot encoding was. And for machine learning algorithms, we need fixed size inputs, and bag of words provides that. So it overcomes one hot encoding's disadvantage of variable vector size. So it can be easily used as an input for any machine learning algorithm. Now, what are the disadvantages? First disadvantage, which was there for one hot encoding as well, sparse metric problem, that remains here itself. Because there are so many zeros and very less number of ones, so the vector is very sparse, which might lead to overfitting in several cases. Now, based on the frequency of the words in vocabulary, the ordering of words happens, like you can see, and the ordering of words is changing. The meaning of sentence is also changed due to the ordering change. That means you are losing some kind of semantic meaning or semantic information due to ordering change of words. The third biggest disadvantage, which was also there for one hot encoding, is out of vocabulary. So say suppose now your vocabulary has been defined based on your existing seen sentences and your vectors have been defined. Now you send another sentence which is junk food is good, junk food is not good. Say suppose we are sending these two sentences. Junk is a word which was not part of your vocabulary. So the new word will get rejected since it is not part of the vocabulary, which is a very big loss because right now we are talking about 3 or 4 sentences. Say suppose we have 100k sentences. In that case, we might have so many unseen words which are not part of the vocabulary, and then you might lose semantic meaning as well since this is out of vocabulary. Now, when we talk about semantic meaning, the semantic meaning does not get captured here, which is really important. When we say semantic meaning, that means relationship between different words in the sentence. So say suppose we have two sentences, junk food is good, which is coded as 11101, and junk food is not good, which would be coded as 11111. Here, the sentences might look so much similar. So the impact of word not, which changes the meaning of this entire sentence in its entirety, is not getting captured. So this is also a very big disadvantage of bag of words. Now let us look at the next technique, which might help you overcome some of the disadvantages of the first two techniques, which is the next technique is TF-IDF, which is term frequency inverse document frequency. So here we will be leading by again our first example, which were S1 is Italy good vacation. I have removed all the stop words and lowercase everything. S2 would be beach good outing. S3 would be vacation outing good. Now the formula for term frequency is number of repetition of words in a sentence, like how many times the word is getting repeated in a sentence, divided by number of words in a sentence, like total number of words the sentence consists of. Inverse document frequency can be defined as the exponential logarithmic of number of sentences by number of sentences containing the word. So, and why this score is called TF-IDF is because we multiply term frequency score with inverse document frequency score to get the overall score. So let's look at this example. We have taken a combination of S1, S2, S3 and calculate term frequency and IDF using these formulas. So say suppose our vocabulary consists of 5 words: good, vacation, outing, Italy and beach. Now for say word good, the TF formula is number of repetition of words in sentence upon number of words in a sentence. So good word is getting repeated once in S1, Italy good vacation. So the numerator would be 1 and number of words in a sentence are 3. So the result would be 1 by 3 for term frequency. For sentence 2, the word good is again appearing once and the number of word is 3. So the score would be 1 by 3. Same for S3. The good word is appearing once and the number of word is 3. So the score would be 1 by 3. For vacation, in S1 it is appearing once. So score would be 1 by 3. In S2 it is not appearing. So the score would be 0. In S3 it is appearing once and the total number of words is 3. So the score would be 1 by 3. Outing, in sentence 1 it is not appearing at all. So the score would be 0. In sentence 2, it is appearing once, so the score would be 1 by 3. In sentence 3, it is appearing once, so the score would be 1 by 3. Italy, in sentence 1, it is appearing once, and the total number of words is 3, so 1 by 3. It is not appearing in S2 and S3, the score would be 0 there. Beach, again, it is not appearing in S1 and S3, score would be 0 there. For sentence 2, the score would be 1 by 3 since it appears once and the total number of words in the sentence is 3. Now for inverse document frequency score for these words, we will use this formula log E of number of sentences upon number of sentences which contain this word. So for word good, log E of total number of sentences, which is 3, divided by number of sentences which contain good, which is again 3. So log E of 3 by 3. This value, when you calculate it, will come out to be 0. So it reduces to 0. Vacation will come out to log E of number of sentences, which is 3, divided by number of sentences containing the word vacation, which is 2. So log E 3 by 2. Similarly, for outing, the calculated score for IDF would be log E 3 by 2 since it appears in 2 sentences. For the rest of the words, Italy and Greece, they are appearing only once, so the score would be log E 3 by 1. And for calculating the overall TF-IDF score, we will be multiplying the TF score of each sentence with its IDF score. So now, final TF-IDF score can be computed this way as shown here. So for word good in S1, 1 by 3 is the score for TF and IDF score is 0, so they get multiplied. In S1 itself, the score for vacation is 1 by 3 and the IDF score is log E 3 by 2, so they get multiplied. For outing, the score is 0 in S1 for TF, so the overall score will also be 0. Italy, the score is 1 by 3 for TF and log E 3 by 1 for IDF, so we multiply them. For beach, the score would be 0 since it doesn't appear in S1. Same way, we'll be computing the multiplied score for S2 and multiplied score for S3. And this will be your overall result for TF-IDF. So that's how we calculate our TF-IDF score. Now, if you see that the word good is repeated in all 3 sentences, so it is very less significant for semantic meaning. And since it is appearing in all sentences, it is very less significant to be tracked. And hence, its TF-IDF score in all 3 sentences is 0. While the other words which differentiate between these sentences, like vacation, is there in S1 but not there in S2, so its score is non-zero. So that's what you want to retain the semantic meaning of the sentence. Now let us look at the advantages and disadvantages of TF-IDF. The biggest advantage of this technique is that it is very intuitive, it is easier to implement. The second biggest advantage is that it results in fixed size of vectors based on vocabulary size. So the size of vectors is fixed. That means they can be used as an input for any kind of machine learning algorithms. And you can also do feature selection over them. The third main advantage is that it captures the word importance because you are capturing how many times the word has occurred in the sentences, vis-a-vis how many sentences contain that word. So the meaning and the importance of the word is getting captured to some extent and it is very critical. Now disadvantages, the sparsity still exists in TF-IDF resulting vectors. There are still so many zeros spread out which might lead to overfitting. And similar to one-hot encoding techniques and bag of word techniques, out of vocabulary issue still remains with TF-IDF because the vocabulary is deduced based on the seen samples, and say suppose there is another word which comes from unseen record which is not there as a part of your vocabulary, then the word will get rejected or ignored since it is not a part of the vocabulary. So this might be a big disadvantage for TF-IDF in case there are a lot of unseen data in your vocabulary. Now, since we have concluded on advantages and disadvantages for TF-IDF, we have seen what are the advantages and disadvantages of one-hot encoding as well as for bag of words. Comment here which all other techniques you have tried out and what do you think is the next technique which would perform better than TF-IDF. If you like my lessons, please like this video, subscribe to my channel for the next video. Do watch the prior NLP playlist, other videos which are on the same channel for stemming, lemmatization, tokenization, named entity recognition, stop word removal. It will help you formulate a strong basis for the next videos to come as the topics are going to get more difficult. And you would like to know these techniques as well as hands-on implementation for them prior to going to the next technique. If you want me to prioritize some other essential topic, mention them in the comments here. I would be happy to help you out in any way possible. Thank you.